So going back, the molar mass is by definition is the mass of 1 mole of a substance or gram per mole. The molar mass of an element is the mass number for the element that we find on the periodic table. The formula weight in atomic mass unit will be the same number as the molar mass or gram per mole. So using moles, if you have moles, you can convert it into grams using molar mass. And also, if you have moles and you want to convert it into formula units, you use Avogadro's number. Moles provide a bridge from the molecular scale to real-world scale. So the number of moles correspond to the number of molecules, and 1 mole of any substance has the same number of molecules. So mole relationship, as you would see here, so 1 mole of atoms, ions, or molecules contain Avogadro's number of those particles, and 1 mole of molecules of formula units contain Avogadro's number times the number of atoms of or ions of each element in the compound. So you would see here in the table that relationship. So finding empirical formula would generally give you this. So if you have the combustion reaction CNH and ON or the fuel plus oxygen forming N carbon dioxide plus half of and water. So that medyo nag-move lang supposedly yung NCO2 there, but should be would be equal to NCO2. The compound contain carbon, hydrogen, and oxygen are routinely analyzed to combustion in a chamber like this. So you have there the picture. So if you're going to calculate percent of carbon, you would determine it by the mass of carbon dioxide, and if you would determine the percentage of hydrogen, you would determine it by the mass of water. And if you're going to determine percent oxygen, you will determine by the difference of the carbon and the hydrogen. Okay, so if you're going to calculate for formula, empirical formulas, you have here percent mass of elements, and then you assume 100 gram sample, and then grams of each element will be determined, and then use the molar mass to get the moles of each element, and then from there you can calculate mole ratio and then empirical formula. So one can calculate empirical formula from percent compositions. So these are just an example, but we will not be discussing here for the chemistry for engineers. But okay, next is the elemental analysis. So you can analyze each of the elements using different methods. So analogous for carbon, hydrogen, and oxygen. So you would see here naman is stoichiometric calculation. So for molecules, you can say for a certain reaction, so you have, for example, 2 hydrogen gas plus oxygen gas forming water. So the one there you would see here is yung H2. This is 2 mole of hydrogen, and this part here is oxygen. So this is 1 molecule of oxygen will form 2 molecules of water. So this one also have 4 atomic mass unit because 2 there, and then you have here 32 because O2, 16 plus 16, so it becomes 32. And then you have 2 molecules of water, so 18 yung atomic mass unit of water, so that becomes 36. So in terms of amount, you would see there also in the grams. So 2 moles here because 2 here, and you have 1 mole there because 1 there, and you have 2 moles here, so 2 moles. And then the next one is you have 4 grams of oxygen here, of hydrogen, sorry. And then you have from there, and then you get 32 grams of oxygen from this 16. plus 16. So, and then you have here 36 grams of water from 18 plus 18 equals to 30. So, stoichiometry calculation would give you this. Grams of substance would give you molar mass. You can use molar mass of A, and then we can get there moles of substance. And then if you're going to use coefficients of A and B from the balance equation, you will get moles of substance B. And then if you're going to use this molar mass of substance B, you can get the mass of substance A.